The most frequently asked question is, what is the best module based on the TPA3255? And you noticed I didn't say Chinese because the best module is not Chinese. But to answer this question, yes, I picked one module for you that I think is very, very good, and it really sounds amazing. But let's look at the different options that have been developed there, especially the Chinese. They've developed such a variety of different modules, and let's see. Each of these modules has some kind of idea behind it. It has some feature that makes it competitive. And I'd like to look at it together with you in a more philosophical way. At the end, I'll show you one unit that I think is the best, also among the Chinese ones, and we'll measure it. But first, let's go through all the units. And when I said that the best unit is not Chinese, yes, it's Ice Power. It's also a unit that's based on the TPA3255 Ice Power 200 AS2. It's designed the right way. Basically, it's very reliable. There's a specially designed power supply integrated together, and it's quite compact, small in size. Yes, if you look at it, everything is so nicely made in a single case. On one board, there's a large power supply, about 300 to 350 watts, and the amplifier unit. There are also balanced inputs. Overall, it's the best in its niche. That's one of the reasons why I didn't make any products using Chinese modules. But for this module, I made a product. I have a small kit like this. For those who want to assemble it, we can build an amplifier like this. I sell it there without the module, with all the connectors, and you buy the module, attach it there, install the connectors, and the kit is ready. You have an excellent amplifier. On my English channel, I sold quite a lot of these kits around the world. Basically, everyone is very satisfied with the result they get. Well, this is a very simple, decent amplifier. It's easy to use, for example, in recording studios. It's quite accurate in this regard. Not perfect, but accurate. It's compact. All the thermal parameters are very well balanced. It doesn't overheat under any conditions. It has a minimum of necessary connections and works well with so-called audio interfaces or external sound cards with microphone input. In professional settings, many people use it for recording. For example, this very same, I'm recording this video using such an audio interface and a good microphone, and then it's easy and simple to record everything. But for those who asked the question, they didn't ask about Ice Power, they asked about Chinese modules. And here, I typed it into the search engine, and we see a large number of these modules. I also entered parallel bridge tide load because then it shows all the varieties of these modules. But to properly evaluate the Chinese modules, let's first take a look at what the reference design looks like. Texas Instruments provides the reference design. Here it is. I specifically chose this picture. Well, if you look with this reference design, we can test all the functionalities, all the connections of this TPA3255 chip. And look, the heatsink is quite small, but we have to keep in mind that this heatsink is more or less we can use it for testing. If you put it in a closed box, there will be problems. But in open air, it passes all the tests we do, though not for 24 hours, but we can check different things at full power and so on. And so on. Well, here are the inputs. Yes. What should you pay attention to? Pay attention to what type of coils these are. These are the toroidal coils. This note has a certain meaning. Then there are several capacitors on the board, and here large capacitors are hidden on the back side. On the Texas Instruments page, the schematic diagram is also provided. And almost all Chinese units, especially in early production, were based on this schematic diagram. Practically even today they haven't changed much. But what's important is that there are 2 channels in this TPA3255 chip, and each channel has a pretty large capacitor, 4700 microfarads. And with high voltage. In almost all Chinese designs, this capacitor is missing. When you're building a complete design, you should also have a large reservoir capacitor for good bass. Also in their reference design, this is provided for engineers so that they can test the maximum possible quality of this particular microchip. Texas Instruments offers inexpensive NE5532 op-amps. Specialized operational amplifiers for audio solutions. This is a good op-amp. It is used in many circuits and solutions for audio processing. As you can see, there are no exotic components here. It's cheap and good. We don't see any noise there. In the reference design, both channels are identical because they can be connected in both balanced and unbalanced configurations. And one more thing you need to pay attention to is how the auxiliary supply voltages are set up. It's done neatly, the right way. So basically we have a high voltage, then it can change, which powers the microchip from 24 volts to 48. Anything higher is already pretty exotic, up to 48. This means that if we use a linear regulator, a very high voltage will drop across it, and it will get very hot. This difference that drops across it, and the current it has to pass through, means this drop causes a lot of heat to be generated. A lot of power is dissipated on it. That's why we can't do it this way. Moreover, this power changes depending on what input voltage we supply to this microchip. That's why a step-down voltage converter with a high efficiency is used here, very high, and here we get 15 volts, and from these 15 volts we further stabilize it down to 12, and also to some additional auxiliary 12 volts as well. If you need to precisely control things like electronic volume and so on, then we stabilize a second voltage as well. These all use little power. We can do it this way. It's important that the part that steps down to 15 volts is built using a high efficiency circuit, but nowadays that's not a problem at all. But also this chip here needs to have an operating voltage above 50 volts. Sometimes people cut corners with that too. You need to check all these things in the boards you choose for more or less serious applications, especially those from China. But let's get back to the Chinese modules. Well, here's one thing. I haven't tested this module myself, but you can see that there are large capacitors, and there are also quite large coils on this module. It will probably be good enough, but it's a bit expensive and there's only one channel. I'm not even considering it. There are more successful competitors, but this one caught my attention. Well, let's take a closer look at this particular unit, where there are more pictures. It has a fairly large U-shaped heatsink, and that cools it well. And from my point of view, it's a good design when we're working without a fan and want to get the maximum output power. There are two channels here, and it operates in a parallel bridge configuration. But what they have rather cheap output filter inductors. They're cheap because they're not potted in any compound. And if you, well, let's say connect it to a resistive load without sound and apply high power, you'll hear a slight rattling. But it doesn't really affect the sound. But overall, if we're talking about good manufacturers, they additionally fill them with compound. I'm not sure with what, but it gets very hot. Simple paraffin won't be enough. There should be heat-resistant silicone here, for example, one that also conducts heat. But otherwise, the size of these ferrite cores is enough to get full power into 4 ohms. With 8 ohms, it's no problem. Well, let's take a look at this one too. This one is new. I haven't tested it myself. Just out of curiosity. Curious. Well, here it is. Transaudio. So what comments can we make? Very good output filters. Very. I also like these output connectors, because these push-type ones are also used in the automotive industry. They can handle an enormous amount of current. They are good and reliable. Well, where do I have doubts? Well, it's obvious that the heatsink is too small. You definitely need to install cooling here. There should be a fan. Yeah, and don't try it without a fan. It will definitely overheat, but overall, it's a bit expensive, and there's only one channel here. 40 plus shipping. It comes out to 50 euros for one channel. Well, to make something really worthwhile, it turns out to be too expensive. All the designs are close to ice power. From a business standpoint, it doesn't make sense. I bought this one, tried it out, measured it. I have detailed measurements of this unit in English, but let's just see how it looks in practice. Here I assembled this little amplifier, which can deliver full power, and it will be completely cooled. But it has a serious problem for operation for a 4 ohm load. These coils are too small. Well, if you don't know any better, the bass will seem more or less okay. But it slightly restricts the bass, and when you've worked with different designs, you can hear it. Well, I can hear it. So this unit is designed for 8 ohms. Only for 8 ohms. It's both tuned and designed for 8 ohms, and at 8 ohms it works amazingly. And you can get, at 48 volts and 5 amps, you can get almost 100 watts of such clean power. Almost 100 watts. Well, that's a lot, and if you have an 8 ohm load, this unit will handle everything, and everything will be absolutely perfect. It also had a development issue where you need to install this resistor and set the sensitivity. You need to set the sensitivity to maximum, and you need a volume control. And if you set it to other positions, you get noise from the fan. There's something wrong with the control setting. But overall, the unit is good, it's small, easy to integrate, and with an 8 ohm load like this, you can make a little gift amp. A product? No, it's not a product. There are a bunch of Chinese makers who are trying to do the same thing in different ways. I'll give this as a gift, maybe to my son or someone else. When he visits his friends, he can hook up big speakers there. Big speakers will work great there. But otherwise it's pocket-sized. This unit has some variations. Let's see. They're trying to improve it somehow, make it better, but until they improve the output filters, it only works with 8 ohm speakers. Here's my second favorite. Not my absolute favorite, but it's a very decent unit. Very decent. Let's take a closer look. Here it is. Also using a parallel bridge circuit, also on cheap inductors, but these don't ring. I tried, these are better. They have a cooling fan. We can use it at full power. But of course the fan will make a bit of noise. And trust me, this isn't the most expensive fan. Or you can see that you're replacing something. But here there's a system where the fans have thermostats and turn on when needed. Well, in general, if the fan noise is loud, it will be annoying. But on the other hand, it fully delivers on everything it promised. And you can get a true 250 watts per channel at 4 ohms. 250 watts per channel. So how does it look in practice? I tested it and measured it. Here it is. Look, you can put a small box like this. It integrates perfectly. All the power-up stuff and so on. And I would say that this is a good solution, except for the fan. But maybe it's not that important. If we're playing at some kind of home event where people are talking, of course it doesn't matter, but for hi-fi or high-end. And another downside, it's set up for an 8 ohm load. And here I really don't see the point. If you use a parallel bridge circuit, it can work with 2 ohms. Why set the filter for 8 ohms? But the filter should be set for 6 or 4 ohms. I would set it for 6. Not even for 4. But in practical use, that's not really that important either, because at high frequencies, the tweeter's own impedance rises to 6, or even, for some, up to 8 ohms. It's kind of, the response in real life will be flat, but still. But overall, I have nothing to criticize about this unit. From an engineering point of view, it's well designed. Here are large capacitors, the ones that, it's also quite a clever design. They handled it intelligently. If you want, I recommend this unit. I've checked it and it works reliably. This is the updated version of the previous one, where I said that if you turn this adjustment of sensitivity, noise appears. Here is the updated version. It has two options. I bought one where the volume control is kind of separated. And let's see how it looks. Well, for the same tasks, it only works with an 8 ohm load. It's set up for an 8 ohm load. Perfect. There's absolutely none there. And since I bought it with the control mounted separately, it turned out that this wire picks up interference. If you turn the volume all the way up, you can hear the interference. It has quite high sensitivity. And in general, well, I'll have to redo all of this. And I even think that I will connect them with unshielded, really short wires like this. But it's not great in this regard. Otherwise, they solve the problem of the loud fan. And this one isn't loud. And I would say it's a very good solution for an 8 ohm load in every respect. Except for this, and it turns out that we can only use one of these units because otherwise everything here will also resolder it, and I'll do it as an experiment, but it's not great. Yeah, it's not great. So it turns out that the key model is this one. In this regard, for an 8 ohm load, if you want that kind of stable, well, a 100 watt amp is good for an 8 ohm speaker. It will sound great. And we can also make it into a kind of gift item in a very small box. And we can even bring this input to the front, and it will turn out, well, almost such a perfect miniature solution to make it as a gift for someone, especially when it sounds this good. Well, that's fine. So, 48 volts for the power supply. 5 amps. And it will drive an 8 ohm load or an 8 ohm speaker better than many, many big amplifiers. And it sounds good with an 8 ohm speaker, but with a 4 ohm one, these small inductors with thin wire, that's not good. The bass drops off. But overall, I rate this unit highly, especially considering the price. That's 25 euros. Come on. With shipping, yeah, with shipping. Well, AliExpress determines my location by IP address, so this shipping is correct. Yeah, I checked this one out. I clearly didn't like it. Well, and from the point of view, why don't you make such amplifiers? Like iYima a 0770, no, 59. Ready-made. For free. Well, of course, it has thermal limitations, but I think it can definitely deliver 70 watts. And everything here is ready. Yes. But they did some things right. For example, they installed the inductors correctly. So in any case, for 59, it's worth it. These are the ones the Chinese make, but you have to realize that everything here is cheap. This volume control, it's going to get scratchy in 6 months, or in a couple of months. Of course, you can replace them and so on, but there's also this price range. We bought it, played with it, then tossed it. And if you, I don't know, launch some kind of gaming stuff there, why not? It's great. And in this case, this one will also work with the 4 ohm load. It has good filters. And for good reason. It says high power red, yellow inductors. Good inductance. They also held this one down somehow. The big capacitor too. Overall, I can't say anything bad about this design. They're on the right track. Mostly they failed due to thermal issues. That's the problem. Overall, the price is amazingly good. Even buying a separate unit, that's a big question. A really big question. Just the unit itself costs about, well, 35. And this one at 59 is already fully integrated. This work is worth it. What can you improve? Well, probably the cooling, and then it will work well. And here is my favorite. Yes, I think in terms of quality, this is the best one today. It has its own advantages. And let's see how it looks on camera, not from pictures. But before we look at it on camera, I also want to show you some interesting marketing. So, the prices for those who understand electronics, and for those who don't understand electronics. Marketing can charge double the price. This version comes with different operational amplifiers, and they doubled the price for you, but there will be no difference. So, this one is my favorite. This one is my favorite. And it's well made, but if you look at it right away, it's twice as big. It has a big fan. If you think that this big fan doesn't heat up with 48-volt power, it does heat up. There are two chips here. And in the TPA3255 each chip, without a signal, it gives off 2.5 watts, and the other 2.5 watts are somewhere here on the inductors. These are the key things that heat up. So it turns out one chip, another chip, two chips, 2.5 watts each. That's 5 watts of pure heat. And when it's running at maximum, even more heat is generated. Basically, there should be convection. No matter how or where you integrate it, you need convection. What else? This unit has a plus-minus 12-volt converter. It's here. It creates plus-minus 12 volts. These plus-minus 12 volts power all the front-end op-amps. And those who are familiar with electronics know that we immediately get a very large dynamic range. And basically the entire preamp stage with 12 volts will sound much more convincing. And basically this unit, if you put it in some nice box, no one will guess that this is a TPA3255 and they'll say it's a very good amplifier, and so on. It sounds amazing there, and it can really deliver 2 times 250 watts at 4 ohms, really. If the power supply can handle it. In general, this one is my favorite. I even measured the capacitor that's installed here. It has low internal resistance, which is rare, but there's only one. That's not enough. It should be maybe a bit more, but overall, everything works perfectly. When customers come to me and ask different questions like how something sounds, when I show them how the TPA3255 sounds, they're shocked. Are there any flaws in this unit? Yes, there's a serious flaw, and it's not the fault of the electronics engineer, but the process engineer. So, how is the heatsink attached? To make it neat, there should have been these spacer washers. Spacers is the English name. On the chip itself, it's 1 millimeter, somewhere around 500 microns. That's 0.5 millimeters, or 0.7 millimeters. There should have been these washers, and then you screw it on tightly, and the pressure from the board presses the microchip. To the heatsink, that's it, everything is fine. But here, if there are no washers, it turns out that the heatsink sits a little crooked in relation to the chip. There's an air gap there. The heat isn't dissipated, and the board will burn out. That's exactly what happened. See, here it's made like this, without those spacer washers, and that's not a reliable design. But in this case, let's see how easily this can be fixed. Very easily. There are these washers from insulating ones for 2220 packages. You know, those big transistors. And if you drill the holes here a little larger to about 4 millimeters, they fit perfectly, and just about 0.6 millimeters comes out on the other side, and you get a perfect washer. And this modification is necessary, so this is how it looks. See? You thread it through and everything turns out perfectly. We make this modification, and then the unit is in perfect condition, but this modification is necessary. So how does it work? We installed these additional spacers, these little insulating washers, and then everything works perfectly. We tighten it firmly. The tension is determined by that small gap, which is 0.4 millimeters. Everything fits and holds tightly. I ran tests under a very serious load. Everything holds up. This heatsink heats up well and quickly. which means everything was done correctly. If it heats up slowly, heat isn't being transferred. If it heats up quickly, heat is being transferred. Well, that means we ended up with a good, solid design. Unfortunately, this modification is necessary. Let's do some basic measurements now. I'll just show the oscilloscope and tell you what I'm doing. So we turned it on. Everything's great. As you can see, the polarity also matches. At 1 kHz, it's about 5 to 10 watts. The signal is excellent. The signal is excellent. And at this level, we'll do all the key measurements. But first, I always want to check how the filter is set up. And here, the filter for 8 ohms has a slight rise. Da. So this filter is probably set for 4 ohms. And let's look at 4 ohms. Almost perfect. In general, I think it's set for 6 ohms. That's the best thing you can do. All these amplifiers should be set for 6 ohms. Then they will work almost perfectly with either a 4 or 8 ohm load. I would say this is an excellently tuned unit. And that's why it sounds so authentic. If you look at the square wave, perfect at 50 Hz. Well, almost perfect. And at 20 Hz? Well, that too, it hardly drops at all. That means the input circuits are very well designed. And as I said, these 12 volts, it makes sense right here at 20 Hz. Let's look at the triangle wave. Perfect. If the capacitors in the input circuits are too small, it bends like this. But here, it's almost perfect. Perfect. It's the best of all the units whose input circuits I've seen. There are absolutely no flaws or problems here. And all these little details, they're important, and in this unit everything is done very neatly, very neatly. And let's do one more important measurement. Maximum power. Yes, maximum power. I'll increase it to the limit, and let's see how it behaves. This unit. Let's also set it to 1 kHz, and now I'll increase the amplitude up to the limit. Well, let's go up. Higher, 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 higher. Higher. It limited us, and let's move back, back, back. Right now we have a perfect sine wave. Well, probably... Yes, well, here it's at no more than about 1% distortion. I would even say a little less. So we can recalculate and we get 32 squared divided by 4. That's about 256 watts. I also checked this Minwell LOP 300 power supply, which can deliver 450 watts at peak. At 4 ohms if we connect both channels. Now let's see what happens if we connect both channels. Because the amplifier itself can handle it, but of course we need to find a power supply that can handle it. If we connect both channels, you see, it limits. It drops a little bit. Let's see, let's lower the maximum amplitude a bit. How much can it handle? Well, about 30, yeah. So at 30, that's it, it doesn't drop. So that's 900 divided by 4. With this power supply we get 225 watts. Well, at 8 ohms, of course, it's half as much, but still at 4 ohms with a good power supply, we can get 250 watts of clean power. But this is a monster, yes, this is a monster. So it passed all the tests. Of course, you have to think about heat dissipation. I would say, if we're working with a 4 ohm load and a 48 volt power supply, you need active cooling. Well, at full power, if it's an 8 ohm load, then there are no problems at all. But with a 4 ohm load, you need active cooling, you need a fan. But it sounds great though. I have an idea to put it in a box so that no one knows what's inside, and give it to some very critical audiophiles for testing without showing them what's inside. And listen to what they say afterwards. Because this unit really works perfectly. Well, all the measurements showed that everything is great, and so on and so on. Is it possible to make a product with such a unit? Well, I would be very careful. First of all, those units that are not produced on the same large industrial scale as products for professional use. Their issue is that the unit is available one day and not the next. Plus, when you sell it, it comes with a 2-year warranty. So I definitely wouldn't make such a serious product, but we can talk about what kind of product would work. Let's imagine that I would make a product like this. I'd paint it, make different labels, put nicer lettering on it, and so on. Would it sell or not? No, it wouldn't. Because with this form factor, the whole market knows that the Chinese make small ones, whether they're kind of lousy or not so lousy. The whole market is flooded with Ayima and Duke Audio and who knows what else. With this form factor, you won't get anywhere, you won't get any product out of it. Even though the unit sounds amazing, which version would actually take off? Some time ago, I developed a universal unit for amplifiers where you can install different electronics and outputs. It has the classic standard of a traditional amplifier with various outputs and form factor. And if you install a unit like this, with this type of case, people will say, cool, yes, very good. And if you use this kind of case, do all the nice finishing touches, the labeling, and so on. In terms of sound, if you use this unit, no one will be able to tell that it's based on the TPA3255. Everyone will say that it's a very good amplifier, and until you tell them what's inside, you can sell it. You can sell it as an amplifier of this size with a power of 2 times 250 watts, and that would be fair. With the right power supply, I use a Meanwell power supply LOP 300, which can deliver about 450 at its peak. And the result will be very good. Basically, well, let's say you can sell such an amplifier. I would say that business starts at around 250 euros, if you can sell it for 250 euros. First of all, any buyer will be satisfied. It will drive any speaker. And these 250 watts, that's the minimum power where you'll notice a difference compared to a 100-watt amp. Well, the old ones and so on. It will outperform the old 100-watt amps by a mile. And at the same time, this unit is designed, it can work with a 2-ohm load, which means it will also handle any demanding speakers. Will I be making such amplifiers? No, I won't. It's purely a theoretical calculation, just a discussion. I only make such products using industrial units because there are a lot of requirements for warranties, reputation, and so on and so forth. But for enthusiasts, I would say this is an excellent design, especially when you need to demonstrate something to someone. But all those who say the TPA3255 is junk and worse, that's not true at all. If you do it properly, this one is done properly. That's why I think that among the Chinese units sold in large quantities, this one is well thought out, and I just can't understand how it's possible to make such a board for that price. I'm an electronics specialist myself. I worked in modern electronics manufacturing myself. You can only make it for that price if you stole all the components. Or if they were left over from big projects and so on. I just don't get it. Maybe someone in the comments, someone closer to China who knows from the inside, can explain how it's possible to sell a board like this for 35 euros. So shall we sum it up? The very best unit. This here is the Ice Power 200 Ace 2. It's polished, excellent, and sounds perfect. The finished product costs about 270. If you make it yourself and buy the kit from me, then there are ready-made Chinese ones. There are some for 170. Overall, they sound, well, not great. They all have some flaws, mostly temperature-related. But they have a lot of knobs and nice analog meters. For that price, it's quite decent. If you take this unit, it sounds better than those industrial Chinese ones. Everything here is done properly. If you fix these issues related to heat dissipation and make that small improvement, it will sound better. Yes, it will sound better. Well, all those people who ask what you think about this unit, that unit, this unit, well, it's impossible to buy them all. I've already bought the most interesting ones, but new ones keep coming out all the time. So, well, you know, I've given you the basic theory. take a look. And those who want to dig deeper, well, take the risk with those 30 euros and try it yourself. You can't buy all the units. They keep getting added more and more, new ones and new ones and new ones. For now, I only have 2 units that I consider interesting for certain projects. This one, the one I showed, there's also another 4-channel one that's been on the market for 4 or 5 years. It's very well made, I really like it. Especially in multi-channel systems where it works exceptionally well on the mids and highs, because it's made as a one-to-one copy of this reference or benchmark design. Well, we didn't look at it today, we only looked at stereo and power. And for all those who are interested and want to do something, well, go ahead, go for it.